Good, so solve. Here when we solve, we're going to be finding the answers to. I don't know. That's weird. Okay. Okay. So when we solve, we are finding the answer, or we are undoing. Today, when we find the answer, which variable would we solve for usually? Normally we're solving for x. So we're going to get an x equals. All right, you're going to get a glue in. I'm going to glue it in on the left side. I'd recommend either gluing on the left or on the right side. You don't need to cut it or anything, so just glue on one side or the other. Yeah. All right, so go ahead and glue this in either on the left or the right side. And then you are going to want a couple colored pencils today, or you can use highlighters if you have a couple colors. Wow. Amy, carry you over it? Oh. I don't know. You can do it. Team, a real short notes today. All right, so gotta get that glued in. All right, so usually when we solve by graphing, we would take time. This would be a multi-step problem. We would first take our time and graph it. Then once we graph it, then we would solve it. However, we spent all day yesterday graphing, so we're going to say we did that. We'll check it off our list. We'll say, yep, got it. We're done. Sorry. Okay, so if you take a look at our first quadratic here, it actually matches our quadratic we did yesterday. We actually already graphed this. We took time to go through it. So I just wrote down that graph, put it on a graph for us. Y equals negative x squared plus 2x minus 3. Okay? So our first thing that we're going to solve for is x. And I'm going to write this out over here. We're going to have negative x squared. Well, our directions are to solve, I guess. Plus 2x minus 3 equals negative 6. So our goal is to find the values of x that make this true, where we get an answer of negative 6. So if you look at your graph, is there anywhere on the graph where the answer or the output is negative 6? When you think of outputs, which variable usually means output? X or Y? Y, yep, you got it. So as I take a look at this negative 6, this is where I'm going to start using colored pencils if you want to grab one or a couple, or you can grab your highlighter. Negative 6 is our Y. It's an output. So I'm going to find that negative 6 on my y-axis. It's right here. Does my parabola have any points at that negative 6? Doesn't matter what my x is, anywhere along that line of negative 6. Yeah, there's a couple. So as I take a look at that negative 6, I'm looking across to see where does that line intersect negative 6? Where do they touch? How many times does our parabola touch that line? Yeah, 2 times. Okay, you got it. Let's actually start saying it. Okay, so this has 2 solutions. There's 2 answers. And we want to find out what is the x at those points. So when I look at these points, we have one point here. Zoom in real quick. That's negative 6. There's a point right here where it hit that negative 6. What is the x that goes with that point? 3. So x could be 3. Or, now we said there was 2 solutions, so we need to name the other one. So that was on this side. As I follow that parabola, it hits again on the other side. So I'm looking for the x that goes with this point. So if I follow that point up, it hits at negative 1. So x equals 3 or x equals negative 1. And that's our answer. Okay, yesterday we did the table for this. I'm going to flip back just for a moment. This one is easy to look at for the table because how many times did we get negative 6 as an output? 2 times. What was the x for one of them? Negative 1. And what was the other x? Now that y was negative 6, what's the x? 3. And so those are our answers, is negative 1 and 3. Okay. All right, we're going to keep working on this one here. We got 2 more that we'll do. We have negative x squared plus 2x minus 3. That part's going to stay the same because we're still looking at this graph. And that's what this graph is the negative x squared plus 2x minus 3. So we have to start with that for this graph. This time we're going to say equals negative 2. Okay, so I'm going to switch colors. If you'd like to switch colors, you can. So remember our goal for this negative 2 is to look kind of like on our y-axis. It's our output. So I'm going on our y-axis. I'm going to go down to negative 2. As I look across negative 2 here, how many times does that hit my parabola? Yeah, it only hits it 1 time. So how many solutions are there? 1 solution. So we do need to find the x at that solution where it hits it that 1 time. What is the x where it hits it this 1 time? Yeah, 1. So x equals 1. All right, last one for this graph. Struggling. There we go. So again, we're going to start with the same thing because it's the same graph. We're not switching graphs yet, so it's going to start with negative x squared plus 2x minus 3. So remember, this is the problem. You're not making that part up. And this time we're going to say equals 1. Okay, so I'm going to switch colors. Last time for color switch here. I'm going to do 1. Okay, that's our output. Is the output the x or the y? The y. So as I look for 1, when I look at my graph, there's kind of 2 1s that are there. There's this positive 1 this direction, and then there's a positive 1 in this direction. Which one are we looking at? The one to the right or the one above? we look at a y, is y the one to the right or the one above? The one above, yeah. So we're looking at this one up here. How many times does my parabola hit that blue line? No times. How come? Why doesn't it hit the blue line? What does it mean if it doesn't touch it at all? How does it not touch it at all? Yeah, it's no solutions, because what happens with our parabola? It goes up, up, up. It hits that -2, then what happens? It goes back down. It doesn't ever get all the way up to that 1. So this one is no real solutions. We're going to put in that word real, because when you're in Algebra 2, you're going to learn about imaginary numbers or complex numbers, which will then have a solution, probably. All right, we're going to do 1 with this next one. This is going to be your test. We'll do 1. If you feel like, if you guys get it with this one problem, then we'll call it good. We'll say, yep, you got it. If you don't get it, then we're going to have to do another one, okay? So we have 2x squared minus 8x plus 4. This was the other one we graphed yesterday. The graph is already done. We went through that work already. So we have 2x squared minus 8x plus 4. We want it to equal 4. So I want to know what are my inputs for those x's so that my outputs are at 4. So I'm going to give you a second. Think about your answer or write it down if you feel like you got it. Use a colored pencil if you need to. See if you understand it. So as we look across, we're looking across at 4. And the 4 is going to be on the x-axis. Oh, nope, what did I just say? It's going to be on the y-axis. So here's our 4. 1, 2, 3, 4. It's kind of hidden a little bit behind that point. I'm looking across. First question is going to be, how many solutions will this one have? So Maya, how many solutions will this one have? 2. How did you know? Yeah, it hits it 2 times. Good. 2 solutions. So now we need to find the x's where those solutions are. We'll get x equals something or x equals another thing. We get 2 answers this time. Dylan, what's one of the answers? 2? Right here? So look at this line where it hits the points. We're looking at this point here and this point here. We want to know what are the x's for these points. Yep, 1 is 4. If I bring down and kind of draw that arrow, that's where our sight line is going. So 1 is 4. One of the answers is 4. And what's the other answer going to be? It's right on the y-axis. So what number would that represent on the x? 0. Nice job, Special. Okay, so that's pretty much what we're doing today, is that idea. So if you need to draw those arrows to kind of show where we got those numbers from, that 0 and that 4, you can, so that way you remember how we did that. I probably didn't do a very good job of explaining it, sorry.